Nice to see so many of you, even people sitting on the stairs. Welcome to Spring Modulith, Slicing Onions Without Crying. My name is Pim Tegelaar, I'm a tech trainer at Picnic, and I've been doing Java development for over 15 years. First, disappointing everyone who thought this was going to be about cooking. It's about architecture. So what is Spring Modulith? It's an opinionated definition of logical modules. And it also allows you to automatically validate this modular structure. It can even document your module arrangement. Raise your hand if you've ever seen an architectural diagram that's out of sync with the actual code. Ooh, that's way more hands than I wanted to see. We've got some work to do. Now, I'm supposed to give you a 1-minute hook to keep you seated here and get you excited about the rest of the talk. But I can do you one better. So validating that modular structure automatically and generating that documentation, what if I told you this can be done in 1 minute? I won't show you right away, but I'll show you during this presentation, so stay tuned. We'll talk about why Spring Modulith, how, events with Spring, and what Spring Modulith adds on top of this. We'll look at alternatives to Spring Modulith, and finally, what we learned from it, using it at Picnic. So you may be wondering, Picnic, isn't that an online supermarket? Yes, but it's also very much a tech company. We have our automated warehouse with kilometers of conveyor belts, robot arms, loading multiple crates full of groceries into frames, bagging machines, lidding machines. We do software for purchase orders, planning, distribution, all that sort of stuff. And of course, most of our backend is in Java. So Picnic in numbers, we've been around since 2015. We have over 250 Git repositories with over 5 million lines of code, which creates 350 microservices. Some are actually monoliths. And we have millions of customers across 3 countries now in the Netherlands, Germany, and France, with over 50 million requests per day. So you can imagine that having a clean, maintainable, scalable architecture is very important to us. In my team, we tried an experiment with Spring Modulith. We used it on a new service. The reason for this is that we had experience with a monolith that got out of hand. There were many package tangles. The modular structure was not very clear and intuitive. And it got so big, we were working with multiple teams on the same monolith. We wanted to extract code to other microservices. But because of all those package tangles, it was super hard to do this. So we thought, next time we want to do it better and start with a clear division of modules from the get-go. So we tried out Spring Modulith. Who here has worked on an ancient monolith before? All right, quite a few. So I think either you've experienced or you've heard of the problems of monoliths, scaling all or nothing, releasing all or nothing, especially if you're working with multiple teams, can be a pain. Compile time, deploy time. I have better things to do than wait for that. A single point of failure. So who of you is using microservice or transitioning towards using microservice? All right, quite a lot. Microservices come with their own set of challenges. You can no longer easily do transactions across microservice boundaries. You can't, if you want to separate your database, so you can't have foreign keys across microservices or entity relationships. We'll now need to deal with data replication, or even worse, eventual consistency. We have to worry about versioning, backward compatibility, forward compatibility. We've also got network overhead. So many challenges. And for this reason, some companies have actually started to transition back towards monoliths. For example, Amazon Prime Video moved back towards a monolith, and they managed to decrease their infrastructure spending with over 90%. Wow, that's impressive. So before they needed S3 buckets to store data, share between microservices, they needed extra load balancers, a lot of extra resources that they no longer needed. But at least we got rid of that spaghetti, right, using microservices. Who actually likes spaghetti? Raise your hand. Keep your hand raised if you like spaghetti and code. Oh, one guy, it can be fun to refactor, maybe. So let's have a look at the microservice architecture at Uber. It kind of looks like spaghetti. Well, what about Netflix and Amazon? They're famous for their architectures as well. Whoa, it's kind of starting to look like a Death Star. Yikes. So how do we prevent getting spaghetti in code? Let's go back to the monolith. Typically, we use an architecture called the onion architecture. Much like ogres, onions have layers. We want to create a layered architecture. And this architecture has been there for decades already and has proven itself. We want to keep our domain as clean as possible, so we don't want to pollute our domain with JSON annotations or Hibernate or JPA annotations to tell us about the outside world, no, just the business domain. Our application layer should only be about business logic. What's nice about this is if now we want to change something in our infrastructure, we want to replace RabbitMQ with Kafka, we can do this without affecting our application layer. So we really limit the impact of changes. Finally, in our infrastructure layer, we'll have things like our RESTful endpoints, our database connectivity, messaging, etc. But what if our onion starts growing and growing and growing? At some point, we might want to split it up. And we can start by looking at our domain. Logically, we can have multiple domains. That's great, but now our application layer is still very complex. It needs to know about all of those domains, so we also want to split that up. And what we'll typically end up with is multiple onions within the same monolith, which is good because then at some point we can easily extract that to a separate microservice. But it also gives a problem. If I want to connect from one domain to the other, I now have to traverse all those layers out and in, including serialization, deserialization, unnecessary complexity as well. So what do? We want to cut open those onions. We want to slice them. We're going to try to do this without crying. We'll slice off the sides of the onion, and this opens up our application layer. So that allows us, if we have multiple of these slices, to inject Spring Beans, for example, services, and use them in another application layer as if they're our own. Of course, when we're communicating with the outside world, we still want to have our own infrastructure layer. And this also makes it easy if at some point we want to extract this, they're still independent. We could say that these slices are, in fact, our modules. So now we have multiple modules inside a monolith. We've effectively modularized our monolith. We have a modular monolith, a modulith. Sorry. So what do we do? Actually, let's back up a bit again. How do we create a layered architecture? Spring already helps us a bit with this by creating these annotations, REST controller, service, repository. And this typically leads, I've seen this in a lot of places, to common package structure, where you have a controller package, a repository package, a service package. And this has some benefits. Someone new joining the team needs to make a repository. Where do I put it? In the repository package. Where do I find all the business logic? In the service package. My endpoints, the controller package. It's very intuitive. But it also has some issues. For example, what is the default visibility modifier in Java? Yeah, package private, indeed, correct. But if I want to now have my service use a repository, it's in a different package. So I can't use package. I have to make my repository public, which I really don't want. And there's another problem. If you've listened to Martin Fowler, then you know that in order to have maintainable code, it's easy to refactor. You want to have high cohesion and low coupling. And what this package structure does is the opposite. It creates low cohesion and high coupling. If I want to manage stock, I'll create a stock controller, a stock service, stock repository, and it's going to be spread out over all those packages. So not very cohesive. All my controllers will typically need to connect to services, and all my services need to connect to repositories. So a lot of coupling between those packages. Instead, we want what's on the right side. We want to have things that belong together should be together, and as little connections between packages as possible. So how do we do this? Instead of creating these horizontal layers, we can create vertical slices. So now our top-level packages are picking, replenishment, shortage, stock, our domain packages. And you may be thinking, well, that's less intuitive. What is picking? What is replenishment? What is shortage? What is stock? What does that mean? Great. This is exactly the kind of question you want developers to be asking. And now if you open a repository, bam, there's your domain. The kind of information you want to see first. To answer this question, I mentioned we have automated warehouses. We also have manual warehouses where our employees pick groceries for our customers. So we also need to keep track of stock. We may have shortages that we need to deal with, and we want to replenish stock as well. So how are we going to do this with Spring Modulith? Spring Modulith comes with three main conventions. The first convention is that each primary package inside your root package is considered a module. So you don't have to configure it, just based on these conventions, these are your modules. Within each module, every package that's nested deeper than that is considered internal, so it can only be used within that module. And we can have no cyclical dependencies between packages. In Java, this is fine. You can have cyclical dependencies between packages. It will compile, it will run, no problem. But as soon as you try to refactor, extract something out, it's like grabbing hair from a shower drain, or a ball of spaghetti that you're trying to pull apart. If you want to do that cleanly, you'll have to surgically cut each of these individual strands, which is quite an exercise. So how do we do this here? We have our picking package that will become our picking module. Our stock package will become our stock module. From our picking module, we can access our stock module, but we can't do both. That would create a cyclical dependency. And here we have our stock using a forecasting service. The picking service cannot use that forecasting service because it's nested deeper. It's considered internal. This also means that we do still have to make our forecasting service public if it can be used by other packages within stock. Ah, that's interesting. There we go. It was not empty on my machine. Works on my machine. All right. That's better. So we can make it public. It's still not exposed. If we don't want to expose things that are in our top-level package, we simply don't make them public. Now, I mentioned I could do this within 1 minute. Let's see if I can prove this. We have our full screen. Yes. So we'll go to our IDE, where we see these packages, picking, replenishment, shortage, stock, as mentioned. We'll set a timer for 1 minute. Let's go. Add a dependency, Spring Modulith starter test. We'll add a unit test. Let's call it modules test, in which we let the Spring modulus create our modules. We'll create a test to verify, and we'll create a test to document. Where we pass along our modules and we write our documentation. Run it, it should succeed. And we still have time left. You may applaud. So that's how easy it is. So how does this work? Let's switch over to presentation mode. Based on our application is within package. That package is a root package. Every package nested deeper inside it is considered our module. We can also print this out to show this. Well, let's show what this object actually contains. We see that it has a replenishment module, which also has a direct dependency on a stock module. We see the beans that are configured in there. We see our shortage module, our stock module, picking module, etc. Cool. So our test passed. Let's see if we can break some of those conventions, violate them, and see what happens. In our picking service, we are using our stock service. So let's see what happens if we want to inject a bean from the picking package. It can be any other one, for example, the picking repository. This compiles. Java is fine with it, but it does create a cycle. So Spring modulus is going to say no. Our slice picking uses our slice stock, which again uses the slice picking. So we created a cycle. We want to get rid of that. Let's do the other example that we saw on the slides. We have our forecasting service inside the forecasting package. Let's annotate it with service. If we want to use that from within the picking service, Spring modulus should say no. And it does. Module picking depends on non-exposed type forecasting service within module stock. So how can we fix that? One way is to just simply move it to top level. If we run it again, now it's exposed. That's fine. But what if we don't want that? We could also expose it by adding the named interface annotation, which effectively makes it exposed within that module. We may end up in a situation where it's a bit worse. We have maybe some legacy module that's full of these violations. We don't want to individually tag each of them. What we can also do is create a package info.java file and consider this application module to be open. So we can, the default type is closed. We can also say this one is open. Now this whole module and all of its sub-packages can be used. And also cyclical dependencies will be ignored. There's also a middle ground option. Oh, let's remove this. We could also add a package info.java file to our forecasting package and slap a named interface annotation on it. This also makes every class inside that package open. If we want to be a bit more strict and not just use these three conventions, we also want to say from within picking, we don't want to use just any module. We want to be explicit about what we're using. we could also configure the allowed dependencies. So we can say, create another package info.java file, and we say we're only allowed to use the stock module. If we now run this, what do you expect will happen? It complains because we created this named interface. So we have a sub-module for stock, the stock forecasting module, and it's not in our allowed list. So we can also add this to the list. Stock forecasting. And that should be allowed. And now, for example, if I want to also add dependency to something else, maybe the replenishment service, it will still complain that this is not in our allowed list. Module picking depends on replenishment via the picking service, and the allowed targets are stock and stock forecasting. All right. Let's remove that violation again. Now, what about the documentation? I mentioned this would automatically stay up to date. Let's see what happens when we run it. After we run it, in our target folder, there will be a Spring Modulus docs folder that contains a number of plant-UML diagrams and ASCII Doctor documentation files. You need the ASCII Doctor plugin to view those, or the plant-UML diagram plugins to view the plant-UML diagrams. So now we see our documentation. So we see the 4 modules that we've created. We can see that replenishment and picking are using the stock module, and our shortage module is listening to events from our picking module. We also see documentation for each of the individual modules, like from the perspective of shortage, it's listening to picking. We don't care about the other modules. We can see the Spring components that are defined in the service and the events that we're listening to. So let's see what happens if we now start experimenting a bit. So our shortage event, we may say, given the name, maybe it should be in the shortage package. So we can just move it. We'll still have to fix the import and run it again. So we moved it from the picking module to the shortage module. And now if we go back, this should automatically update. So now the shortage module is no longer listening to the picking module, but the picking module depends on the shortage module. We could even create new modules by simply creating a new package. Let's call it API. If we drag our shortage events to that package and rerun our documentation test, we'll first need to, of course, do the imports again. Let's run it again. And go back to our documentation. That will automatically, I think something went wrong. Should automatically update. Oh, I dragged it to the wrong level. Be careful. But that's how easy it is. Even if you make a mistake, you can quickly learn from it. So now we have an API module, and our shortage module is listening to our API module, and our picking module depends on our API module. Neat. But what about our integration tests? So it's nice that our code, we'll switch to a different branch where I have a bit more set up. It's nice that our code is modularized, but if we want to extract code, our tests, our integration tests, what will happen to those? We have now a picking service integration test. And this is an application module test. And the default mode is standalone. And what does that mean? It means that in this integration test, I can only use the modules or code from the modules that I'm using. So I'm testing now the picking service. So if I want to integrate with the stock service, I'll have to mock that stock service. if I now, for example, remove this mock and run this test, I need to refresh Maven first, just a sec. Then this should fail. Because the stock service is not part of this module. I can also change this to direct dependencies, so it will include my picking module and everything it directly depends on. And then I don't have to mock this service, because it will use the actual implementation. If you want to test a full integration test with all your modules, you could even choose all dependencies. Another thing that Spring Modules adds to make these integration tests easier is scenarios. They're essentially syntactic sugar over a combination of the awaitility tool and SRJ. So this allows us to test a combination of asynchronous events, which is nice. So you can either publish events or stimulate calling methods, like we do in this case. We're stimulating that we're doing the pick from the picking service, and then we await for the event of type shortage event, matching the value. So we check if the ID is actually the ID we put in, and we await for this to arrive. So this is nice. Even though it's asynchronous, it can still run easily in a unit test. Cool. So talking about events, what about decoupling our application even more with events? So injecting beans is nice, but we want to decouple from that implementation. And Spring already has a solution for that. Spring Events has been around since Spring 1.1, which allows us to decouple from the implementation, gives us inversion of control. So instead of saying, hey, you do this, you say, oh, something happened, I have an event. Whoever's interested can deal with it. Using these events also makes it easier to transition to external events. If at some point you want to extract something out to a different service, you probably want to use messaging for communicating with it, like RabbitMQ or Kafka. Super easy if you already have events. A lot more work if you're directly using Beans. So what does Spring Modules add on top of this? It has an opinionated definition of event listeners. Spring Modules is saying there's one correct way to do it, and this is how we do it. It will automatically log events. It will also give you the option to store events in a database, an event registry. And using that event registry, we can also republish uncompleted events on startup, which is pretty cool. So you get an outbox pattern out of the box. I'll show you how we do this. In our picking service, we're now using that application event publisher from Spring. To publish events, this is just a record, super simple. IntelliJ also helps us to navigate to the place where this is handled. You can just click on it. So here we handle the shortage event. We print out that we received it. We pretend to do some work. And then we print out that we successfully handled it. What Spring Module is doing here, we have the application module listener annotation, which is essentially a combination of these three Spring annotations. So async, because by default Spring events are synchronous, and to decouple them further, we want them to be asynchronous. Transactional, so if they fail, we can roll back. And the transactional event listener. And this combination makes sure that if the method that was publishing the event failed, you don't want to actually handle this message. So only after it commits its own transaction will your event be handled. Do be careful with that. It also means that if you don't call it from a transactional scope, it will just ignore the message. So let's run this application. I also added, while we're waiting for this to start, I added an endpoint to easily trigger these events. We can open the IntelliJ utility for calling this. So we'll trigger these events. We see that it will trigger the shortage event. And if we open our run console, we see that it received the shortage and handled the shortage. Nice. Now, I added some more stuff to this repo. There's also a dependency called Spring Boot Docker Compose. So when I start my application, it will automatically also start my Docker Compose configuration, which in this case starts a Postgres database. We can have a look inside that database and see what Spring Modulith did with it. It added a table called event publication, where we have the ID of the event, the listener ID or handler, the event type. It also added the actual content of the event. We see this article ID 42. And finally, it adds the publication date on which it was published and the completion date where it was successfully handled. That's nice, but what if it goes wrong? What if we fail to handle that event? If we go to our shortage service where we're handling the event, let's pretend that this fails. We'll increase it, the work we're doing, to 20 seconds, so we have some time to stop it. So our application will restart. We'll wait for it to boot up. We'll trigger this event. We'll do a new one. We can see in our logs that it received the event, but it hasn't handled it yet. So now we're going to pretend that it crashed by actually letting it crash. So it's dead. If we have a look again in our database, we'll refresh it. We see our new event with a new ID. We see the publication date, but no completion date. So let's see. I'll set this back to 1 second so we don't have to wait as long. Let's see what happens when we start our application. We should see that we receive the shortage event and we handle it as well. And now if we look again in our database, we refresh it, we see that that completion date is now filled in. Nice. So the outbox pattern out of the box. There's more out of the box. There's also a new actuator endpoint. We can see a monolith endpoint. So let's see what happens when we go there. Sorry, modulith, not monolith. So in here we see actually the definition of our modules. So it's pretty cool. So you can see an up-to-date description of your architecture as it's running on the server. There's even more that we get out of the box with Spring Modulith. We also have observability. If you're using open tracing, with Spring Modulith, it can add spans to your modules. So for each module, there will be a span. And this is a tool called Zipkin. And you can see within each module where the request spent its time. So first, we spent about 30 milliseconds in the payment module. Then it went asynchronous. And we could see, finally, in our engine module, it spent over 5 seconds. So that's probably where we need to investigate the performance. Do be aware that, of course, it comes with a little bit of overhead. So measure and see if this works for you. Let's have a look at alternatives to Spring Modulith. At Picnic, we like using Maven. So we create Maven modules, and we can do that also to modularize our monolith. And to further create these layers, we'll also have a separate API, data, logic, web modules. I tried to do this for our little sample here. It was already quite a bit of work. You need to create all those package structures. You need to create POM files, explicitly specify each of the dependencies. So quite a bit of work. let's compare the two. In Spring Modulith, your module definitions are implicit. You don't have to define them. It's using the conventions. With Maven, you would have to explicitly create them. Spring Modulith is also super easy to set up. We saw we could do it in 1 minute, and refactoring is easy. You can just drag around packages and it works. With Maven, that's a bit harder, but you do get more control over your dependencies. Especially third-party dependencies is something Spring Modulith doesn't really deal with. What you could still do is do a combination of Maven modules and Spring Modulith. You could have a Maven module to handle integration with AWS, and that module can also be a Modulith module, and then you can explicitly define that you depend on that module from other modules. With pure Spring Modulith, the problem is if I start adding AWS in one module, suddenly these imports are also available in other modules, so not so nice. Spring Modulith is also easy to remove. It took me 1 minute to add it. I can also remove it in 1 minute. Just drop the dependency, drop the unit test, done. If your whole structure is based on Maven, it's a bit tougher to get out. Spring Modulith gives you test time restrictions. The violations, you see them in your unit tests. With Maven, you get them at compile time, so it's faster feedback, which is better. What I also like about Maven is that it has a build cache, especially on larger projects. Each of these artifacts, when you're switching between branches, you don't have to compile. You don't even have to run the tests. You can cache those as well. You can still use it with Spring Modulith, but your artifacts is going to be your whole thing, which will be less efficient. Another alternative is ArcUnit. With ArcUnit, you can verify your architecture by creating architectural rules in unit tests and run them. Spring Modulith actually uses ArcUnit under the hood. It generates these ArcUnit rules and then runs them. You can also use ArcUnit standalone, so you could create those rules manually yourself. Downside of that, if you want to experiment, refactor stuff, you'll also have to manually update those rules. ArcUnit does give you more, though. You can also, instead of just packages, you can also have a look at class names, at annotations. You can do things with third-party dependencies, so quite powerful. You could even use them in combination. What I also really like about ArcUnit is that the rules are very readable. Here we see an Arc rule definition. No classes that reside in a package picking should depend on classes that reside in a package shortage. Check those classes. Very readable. In conclusion, what does Spring Modulith give us? It gives us a convention or top-level packages as modules. It allows us to automatically verify our architecture, generates architectural diagrams. It adds the event publication registry, which is, by the way, of course, opt-in. You don't have to use it. Also, the republishing on startup is opt-in. It adds observability support, which is also opt-in. So what did we learn from this using it at Picnic? First of all, replenishing events does require idempotency. If you have multiple instances of your application running and they all start up at the same time and they're reading from the database, they could handle the event at once. Something to consider. We personally didn't immediately see the value of having these application module tests with standalone, etc. And I imagine that this is especially beneficial at the point when you're actually extracting something and you notice that your integration tests are not standalone. That's when you would feel the pain and you're thinking, I wish I would have had these application module tests. But so far we didn't have this, so we also didn't feel the value of it yet. Something to consider is if you at some point want to extract something to a new microservice, you still have to do with the database. So you could, in advance, create schemas for your modules, But be aware that, again, when experimenting and refactoring, Spring Modulus is not going to do that with your schemas. So something you need to think about yourself. We also noticed that we're using a tool called Juke to connect to our database, which generates code. Spring Modulus actually picks that up, but you can easily exclude that with ArcUnit predicates. It's much harder to apply on an existing spaghetti monolith than it is to do on a new service. So that's something to keep in mind. I mentioned if you have one module that's legacy, you can, consider it open. But what if all your modules have cyclical dependencies and a big mess? You want to exclude everything? What do you still learn from it then? Spring Modulus at its current state also won't give you warnings, so you have to actually remove those exclusions to see the problems, which is not so nice. And on top of this, you have to manually keep track of obsolete exclusions in its current state. So maybe I added an exclusion and then I fixed the problem, but the exclusion is still there. Spring Modulus is not going to tell you, oh, you don't need this exclusion anymore. So you have to manually remove it. Named interfaces, personally, also don't find them very intuitive. When I read named interface, I don't think that exposes something. Not so nice. Also, having rules, architectural rules in your package info.java is not very intuitive. Most people expect package info.java to be about documentation, not about architectural rules. What I really did like about it is that it invites experimentation. So dragging around packages, refactoring. With Maven, that's something people typically just don't do because they feel like it's too much work. What I also really liked is that it led to having architectural discussions earlier. Normally we would have these in pull requests, or maybe sometimes not at all. For example, should something be a domain or a subdomain? We had a freight letter module, so we create a PDF with information about what's in a freight. And inside this freight letter module, we also had logic to create an agreement. Two people need to actually physically write down their signature. So we had an agreement module. Does the agreement module make sense out of the context of a freight letter? Could that be a standalone module? Are we going to use it somewhere else or not? That's something you can now have a discussion on, or you're forced to have a discussion on. Should something be reusable as a module? We added a security util within a sub-package of a module, and then we wanted, in another pull request, to start using that same security util in another module. Spring Modulus says, no. What do? Add an exclusion, move it to top level, create a separate module for it, or maybe even a library. That's the kind of discussions you'll now have more often, which is great. Finally, before we go, I also created a video with a song about evolving code. Feel free to listen to this after, where I replaced my voice with an AI's voice, so it's a bit nicer. Yeah, you can also find the slides, the code for this experiment on GitHub. That was my talk.